are starting in 3, 2. Alright guys, welcome to React Nights Week 2. It's so amazing to see you all here. Because I wasn't here last week and I didn't see you all, but man, a lot of people. How's the homework? It was good? Everyone did it? Almost? Yeah? Okay. Today my topic is project architecture and routing. And after this lecture, I want us to have a solid foundation that we can build upon, because that's where every project starts, right? And to give you a little insight to what we're gonna do today is that we'll have some theory at the beginning, half of the lecture, and half the lecture will be live coding. So we are jumping into the code editor and do some proper coding. I want to mention that you don't have to make probably any notes, or you can, but I want you to focus on the presentation. Same for the live coding, is that you don't have to code with me. The code will be on GitHub, so just sit back, relax, and enjoy. So, project architecture. I want to start with a quote for a programming legend, Robert C. Martin, who wrote many of the books, programming books, but one of the probably most famous one is the Clean Code. And the quote is, "The ratio of time spent reading versus writing is well over 10 to 1. And of course, it differs from project to project, but what I want to say with this quote is that we are constantly reading old code as a part of the effort to write a new code. And therefore, making it easy to read makes it easier to write. What I want to say by that is that this is where project architecture probably comes as an important part, because since we are reading a lot, it has to be good. And I want to talk about what I think makes a good project architecture. So first one, it should maximize how easily you or your colleague can navigate through the code. It encourages scalability and reusability. It goes hand in hand with the previous point, and the point of this is that the good project architecture should make it obvious or where to add new code. And the last point is the good project architecture should be optimized for change. And what I mean by that, and unless you're sending a spaceship to Mars, your code will probably change over time. And what I mean by change, like for programmers, I would say the best change is when you delete the code. So your code should be optimized for that, because you don't want delete the code and then suddenly find out that it breaks a part of your application. And another important part of optimization for change is it should be optimized for moving files around, because as the project goes, you can come up with probably maybe some better abstraction. You did something wrong. It should be easy to do that, to move files around. Now, let's talk about React a little bit. So, React is well known for its unopinionated approach, where it gives users complete control of everything. And this approach is good and bad. Why is bad? Bad because when there are some newcomers, people learning to React, they can't find a good resource of, for example, you have to do it like that, in other frameworks. So usually people rely on some blog posts or on some outdated articles, and it could be a struggle, and maybe some kind of it could be a struggle to just know to just make sure if they do things right or wrong. They may do it right, they may do it wrong, but they cannot know until probably in the future. On the other hand, I think it's one of the biggest advantages of React is that when Facebook open source React, there wasn't a person who said, you have to do it this way. And because they probably didn't even know what would be the best approach anyway. So they leave it for the ecosystem and community to deal with that. And I think, although it can be a struggle at the beginning, it is what makes React great. And over time, there were common patterns and conventions established, but I think that one of the things that is still not standardized is project structure, and that's what we're gonna talk today. And there are two approaches to. There are probably too many approaches what you can read or hear in React and how the projects are structured. The first one is group by type, and the second one is group by feature. Let's go to the group by type. Group by type is, as you can see, nothing hard. You just name it as it is: assets, components, actions, reducers, which will be introduced later in the course when we will talk about global state. But and why it's good? It's good at the beginning because there's no mental overhead. It's like, oh yeah, I have a component, just put it there. I don't care, just put it there. Work. You can start really fast. On the other hand, as the time goes, grows, it gets more complex. This architecture becomes really difficult to maintain, since you can have 30, 40, 50, 100 components in one folder, and that's something what we don't want to do. The second one is group by feature. And by feature, you can probably imagine everything. It could be a route, it could be or view or scene, whatever you wanted. But the point is that feature has everything it needs to work on its own. Should it be like styles, assets, like images or icons, translations, tests, whatever. It's all coupled together. The benefit of it, I think, is it follows the rules of good project architecture. What I mean by that, for example, you can safely delete this, for example, this component, because you are sure that it shouldn't be used anywhere else, because with this we are introducing kind of a scope, and we can delete this if we don't need something from the store, which is again React stuff later in the course. We should be confident that we can delete it. On the other hand, the drawbacks are you have to think about it in advance. Is that you cannot just jump into your code editor or start coding, because you should probably think about it and have a general overall knowledge of how the project should look like. And sometimes maybe when you were working on something, you may came up with a wrong abstraction. So from time to time, some refactoring is necessary. Let's go quickly over what we saw on the previous slide. And so the root folder components, it usually contains components which are shared between different pages. What are pages? Pages are components, but already with a specific use case, and usually visible by the end user. Pages may or may not contain single usage components, which are tied to this page, and they are included in this page so they don't pollute the global scope. Store contains the code that handles global state, again, later in React Nights. API, I think it's really beneficial to separate the server or make some kind of a bridge between the server API and the view layer. So in here you can make your network calls, transform payloads, and your components wouldn't be they wouldn't contain any of this logic. So they just call on one function and everything, the communication stays there. Config.js, it's something what already Danny did last week. This just contains some code that configures the app runtime. For example, like environment variables. But what I probably want to say is that there is no definitive guide on how to do something and how not to do something. And the only thing which matters at the end is how comfortable you and your team working with each other. So don't follow any conventions strictly. If you feel something you want to do differently, do it differently. Learn from your own mistakes. And one more point, which I think was it was hard for me to do, is that not doing like premature optimizations, like abstraction, which I think, oh, this will be reusable in the future, but then nothing like this may happen. So my rule, what I do is that I would rather copy paste one thing twice than making, for example, just abstraction which is not necessary, because it may hurt the project in the future. Alright, this was the project structure. Let's go into routing. What is routing? I think that routing is the root mechanism of how user interacts with the web and your web application, for example. And what are the main functions from user's point of view? It's navigation, it's sharing, and it's bookmarking. So routing is a really important part of the web, I would say, and it's really important to make it right. And we have two types of routing. The first one is server-side. That's not something what we care about today, and that's something what I think we all used to. We click on the link, the request goes to the server returns a whole new document page, browser refreshes, and here you have it. But it's something that's not something what we are interested in single-page applications. On the other hand, client-side routing is routing that is handled internally, completed by JavaScript. So no going to the server, nothing like that. What are the advantages? So the client-side routing is usually faster because less data is processed. It's more seamless because you don't have any refreshes and your app feels more fluid. And you can do cool things like transitions, like an animation between the page changes. Let's talk a bit about the history of the client-side routing. So I don't want to talk about. So of course, when you have single page applications, you may not have no routing at all. But that's not something that I want to talk about today. But in the past, what was done, what was done in some other frameworks is hash-based routing. So imagine this route. So it's just some site.com hash and then some part of the URL. How it worked? Not how it worked. Let's talk about it. The part behind the hash the URL reflects the state of the application. And how it worked is that in JavaScript, you change the part behind the hash, and if you change the part behind the hash, it doesn't trigger the page reload. So you could happily do that, but unfortunately it's unintuitive. People on the web are used to go back, go forward, and this is something. And with that, you couldn't do that. But luckily, with the HTML5, the history API arrived. And the history API provides methods for manipulating with the browser history. So it provides something like window history.back, which goes back, which simulates like you would click on your browser back, window history forward, but most importantly, window history push state. What it does is that it creates a new entry in the history of the browser. So thanks to that, we can simulate the routing, and the URL will change accordingly. One thing I always keep in mind when I want to build logical URLs, something what is intuitive, something what makes sense for the user, is that URL in the browser should reflect the state of the application. So let's talk, for example, about the app we are building here. So if we have a product list, what would users probably what would be a logical URL for the user? So for example, products, because it makes sense for the list. And if you click on the product, so usually what would be URL for that? So I suppose, for example, something like products/ID. So if you share it, if you see it, it's logical and it makes sense. It's intuitive. Before jumping into live coding, I want to talk something about what is called the declarative routing. And I think declarative routing is something what wasn't here before React, and especially React Router version 4. But before that, let's talk about the history. Static routing. If you're familiar with some frameworks like Ember, Angular, or Express on the server, these frameworks declare routes as a part of your app's initialization. So it happens before any rendering takes place. You have a static file, and for example, do I have it here? Yes, so in Express, when you define routes on the server, you define it like that. In Angular, I'm not sure which version it is, but you define it, so it's for example, you place in a file completely different to your application, where you define the path is like that, use component like that, and for example in Ember, again, you define it out of your application, or outside of your application. And prior to version 4 of React Router, it was done, which is probably the go-to solution regarding routing in React apps. It was done in a similar way. You had a file, definition file of routes, and it probably worked. But then the creators of React Router, they said that it seems that like people, when defining new routes, they want to use some life cycles what are already present in React. and they want these features and these features in the React router. And what is said is that they don't like that routing is outside of React, because in React everything is a component, and why they should build something what is not built in what it doesn't feel right for React. So what I did is that the rendering takes place, the routing takes place as your app is rendering. No configuration or conventions outside of a running app. And if it doesn't make sense now, let's jump into the coding and I'll show you what I mean by that. So let's go for live coding. I need to stop mirroring my screen, so bear with me.
Full screen or what?
No, I have my notes for the presentation here, so I want to put my code editor over there. So drink some water.
Sorry guys, technical difficulties again. We just need to share or mirror your screen over there too. Could you just please go back into your that thing? So there's this casting. Yeah, casting icons over there. Sources, yes, please. Now let's see how it works.
Works? Awesome. So, can everybody see the font? Yeah? Cool. So we are starting where Danny left off. Let's create a new branch.
Please move.
I did it. Let's go to a new branch. And let's start with what? Let's first of all start with setup and React browser. It's pretty easy. Let's just wait until you download it. Alright, it's done. So the setup is pretty easy. You just import the browser router. I usually rename it so it's more. And we just put it here. What is browser router? So the React router, it has like implementation of router regardless of what it uses underneath. The browser router is a router which is connected to the history API, what we were talking about. So, but if you would be curious, we have something like hash router, but that's something what we don't want to use. So let's use the router here. Since we are talking about the project architecture, I have a recommendation for you, and it's to divide the imports that are used in the file. So what I usually do is that I'll keep top imports from node modules at the top, And if you would use some kind of path alias, which we'll probably use in the future, what is that? Is that in the future, when tooling has to work for you, is that we imagine we would have a folder components with some components, and we would have pages, and we would want to import something from components. So we would do probably something like, if we would be nested somewhere in the folders, we would have to go back, and then take this component. But with tooling, which we'll set it up later, we can specify the absolute path. So like we could do something like components and some component, and we get rid of this ugly path, which can happen in the future when we have a really big project. And what I do then is that I'll keep node modules import at the top, my components or relative path in the middle, and something what is absolute path in the middle, and the relative path at the bottom. So I can immediately see where to add something and what's included in the file. So I did a little bit of refactoring. We have this, save, and let's start. And we have our app here with the products. So first thing I want to show is that how it behaves right now. No matter which route we put into the browser, nested how many levels we want, we always get the same page. So let's fix that. First of all, I create a new pages product list. Folder, and here are my recommendations different. Some people prefer to actually name it by the name of what the page is. So for example, home, because it would lie at the root of the URL, it's home, but I prefer to keep my names of the pages like not coupled to what the actual URL is, so I can change the URL and I don't have to think about the name of the page. So let's copy it here for now. Rename it to product list. Again, one more tip. Something what I've started using just recently is that there are two types how to export components from your file or module. Is that you can either export it by default, or export it as a named. This is a named export. And what I used to do, and what I also see everyone doing, is that everyone exports it defaultly, but the thing is that when you want to refactor a project, for example, so let me finish it very quickly. I'll show you what I mean. We were talking about refactoring, for example. So what we want to import something from pages product list, and if we would export it as a default export, we could give it a name like this. And it's a good practice to name your component after the file name, but you may be in a team where not everyone is doing that, and they could name it like product list. I just came up with a name, but my product list, because for example, something is already a product list and they don't want clashing the names, they name it differently. But imagine you would want to refactor your code and you will be like, oh, we have a new product list, I want to delete my product list so because I created a new one. So you look out, for example, for every product list in your project and you see that it's not included, okay, it's included right here, but it's not included everywhere. And I can also, alright, nobody's using it, I can safely delete it. But if somebody would give it some other name which you couldn't find, then there could be an issue. What the name export does is that it requires the user to use the name you gave it. So I couldn't just give it the name what I want, I have to use a name export. Name export requires me to use the component by name I gave it. And even if user would be like, oh, I have some different product list or whatever, I need to rename it, they could rename it with a special like syntax, they could rename it to my product list or whatever, but the point is that they will always have to use the name you gave it to, and by that you can always find it in the project. So just a tip, it's not a requirement, you can use whatever you want, but it's something what I find out and really handy. So we just replace it here with the product list. And we don't need this, we don't need this, we don't need space. Oh, we don't need anything. And this rule will give me a hard time, so I'll turn it off for now.
Can I ask a question?
Yes.
And is it preferred inline exporting or like you do at the end of the document?
When I'm lazy and I don't write classes nowadays with the hooks, so I usually use functions. So yes, when I have a lot of functions and I'm lazy, I just export it directly with the functions of my component. Yes, I could do it like that. So no preferences here, probably yours. What is your preference? You can do that. Let's check if it works. Can't resolve conflict, of course. Oh, and we can see how it could get messy. We have only one level deep, and we already have to specify many paths. In the future, yeah. Let's check if it works. It works. Awesome. Next, we are talking about separating the API from the definition of your component. So let's do it. Let's create a new folder called API and have something like get products. Where get products. And we just copy paste code there. But I want to show you something. So this get products needs an access token. But does this component really care about how we get this token? This component only what it has to do is just fetch the products and display them. So what we actually can do now is, let's first refactor get token. I'll take this. I'll put it into a separate file. We need config. It's here. And then get products. What cares about access token? So for now, only get products cares about access token. So let's put the access token getter just here. And I also want to get rid of the promises, not to get rid of completely, but get rid of the then and use the async await. So let's do it together. Let's put it here at the top. And what is async await? Async await is I would say a sugar syntax, which is here to improve our work with the promises and make the code look like more imperative. And let's transform this code from promises to async await. So first of all, we need to name the function async. And one important thing to remember, every async function returns promise by default. And for now, let's just what we need. We just take this code, and instead of like putting then here and then work with it over here, we can transform it. What we do is that we'll receive it here, and we have to put await here. So basically now, if we would do this, this would be a promise. But with await, we get what is here in this then, when the promise successfully resolves. And again, what we need is the JSON, which is over here, which also returns a promise. So we need something like await press the JSON and return JSON. We need config here as well. But we are still missing access token. But let's take it. Let's take it from the file, the token. And what we can simply do is await get the token. Again, this function returns a promise. We can see here, fetch returns the promise. We await the promise, and when it resolves, we'll get the access token and we'll pass it here. And what it makes, let's see what it makes to our component. We can get rid of this. We can get rid of this. We don't need this. We don't need this. But only what we need is get products. Much better, isn't it? Much more cleaner. Now we separated the API from the component. And imagine if, and that's actually what you'll see in the future lecture, but there could be something what is not suitable for us in this response. We may need to transform it somehow. Again, we'll keep it separated from the components, and our components now only care about displaying the data. So let's check if everything works. Alright, everything works, but we still have this problem that every route responds to everything. Right? Yes, we have it. Let's go back. And now becomes the interesting part. The part about what is declarative routing. So instead of creating some new file like routes.js, where I would specify something of the route path should be the product, the app, for example, or product list. Sorry, the product list. I just write React, and what we do in React, we just render components. So what we need to get is the route from React down. And what I do is that, alright, I'll render the route. I want to render it on the path. And what I want to render a component called product list. I just write React. I don't do any config files. Let's check it out. It works here, and it works here. Oh, it still works here. Weird. But
what if you use exact?
yes, thank you. That's what I was going to use. No problem. I'm glad you know. So he's 100% correct. because what it does, it looks if it matches the path. And does it match the path? Oh yes, because there is a slash, and so it matched. So it's like ambiguous match, but as our colleague said, if we add something like called exact, it tells the route that we want to match it exactly. So right now, as you can see, we cannot see anything because this is not an exact match. If we go to root, we can see our products. Cool. Next thing. We want to display a product detail. So how do we do that? Let's, first of all, let's create just product detail. Let's create this simple function for now. So what we do is that we want to render it on some path, like for example, what we were talking about before, something like product ID, and what we want to render. We want to render product detail. So now, if we would go to this route, we would want to see, for example, an ID. But first of all, what we need is that we need somehow to navigate through our app, and that's what another component from React Router is for. It's called the link. What we do, we just simply wrap our list item into the link. What it needs to, of course, and we want to router it to /item.id. We'll have a beautiful purple color, blue, and what it does behind the scenes. We were talking about the history API. So if we look into the DevTools, it's a regular anchor tag. So usually what we use on the web for linking, but it intercepts the onClick event and uses the history API to push the state on top of the browser stack. If we click, we are in product detail. Wow, product detail, but we are missing one part. We want, for example, we want to fetch product detail when we are at this page. So we need an ID for that. And where do we get it? Let's go to React documentation, React Router documentation, and let's have a look. So what it gives us? What if we put our component inside of the route component? So what I mean by that is that if we put it over here, our component inside of the route, the component will automatically get those three props. The first one is match, the second one is location, and the third one is history. The history, it's already similar. We already know what history is. Is the object which we can use then to manipulate the URL. The location is just an object which identifies the current URL. We can have a look on how it looks. Can we? Location, yes. So it has some unique ID, path name, search, hash. We don't use it, and state, which is an interesting thing. And but the thing which is important for us is the match probe. So match probe includes some information about the matching route, what we need. And the first one is the params, and this is exactly what we need. And it's that if we specify some parameter in our URL, we'll receive it here. Then we can have its exact path URL. We don't need to care about it right now. So we go to product detail, and what we receive here is it's a match. And how did we name it our parameter? It's product ID. And that's what we get. We'll get match.params.product ID. Let's see if it works. Go. Oh, it's here. We have it. And now we have everything we need to fetch a product detail. So I'll leave a to-do here for you. Fetch product detail. I won't do that. But what happens if we need some route, which will be, for example, I don't know, about route. So and I won't use component. I will use a special thing called render. The difference between those two is that when you pass component, the root checks for it and uses a React create element method to create the actual component. With the render, it knows it's a function. It will call this function directly. Why it's important is that if you would pass the function here, for example, it would break the React diffing mechanism, and it would create a new component for every render. So for now, if somebody's curious, we can talk about it together. But for now, let's just remember that let's put the component here. Otherwise, something not really nice can happen. Component here, but into the render, we can use the function directly because it knows how to use it. And what we do here is just some kind of like about page, something. So let's go to about. Oh no! It matched two routes. It matched the product detail because, as we specified, this is, for example, some product ID, and it matched about page, which is correct, but it's not something what we want. So React Router gives us a special component called switch, and if we will wrap our routes into a switch, then we'll see a difference, but still not what we want. So now, as you can see, we can see just product detail, and what it does is it goes route by route, and if it finds the match, it will render this component immediately and skips the rest. So if you want to really fix our problem, we need to put we need to put the about page above the product ID, and now we have about page because we are on about page, about URL, and if we click on product ID, we'll have the product ID. exciting stuff. And we have 5 minutes left, and I want to spend it to talk more a bit about the declarative routing. It's not really a use case of ours right now, but I want to explain a bit more what are the advantages of it. So for example, let's delete this, we don't need this right now. But let's imagine that two different teams are working on two different parts of the application. For example, one works on this one and second one works on this one. And they don't know about each other, they work on their own. But in the future, when they work on the product, they realize that they need also some kind of routing, but after this part. And they don't want to just simply, again, add some more routes here, because honestly, it's like this part of the application doesn't care of the implementation details of, for example, product detail. But if this team needs to render something differently on each route, what it can do. So, of course, what they can do is they just import, for example, route and use it as they need. So, for example, if they go here, they can use different block again. So there's a bit more work to do, but for now let's get patched. And for example, let's put switch here on this one. Keep more coding, sorry. I'll finish it now. Hi. But we need to delete this and this. So we just show, it's just an example, not for us, but if we are over here, like you can see that we have this little hello over here. And if I hide, we are still on the root, and not working.
You have these attributes of the element, not, is that correct?
Sorry?
You have those routes as the path and as attributes of the element route, not as a value of the element route. Is it correct way?
This one?
Do it? I mean all of them. I mean the route could be like open and close tag, right?
Yes.
You could put it inside. Will it be better?
No.
Okay, those attributes. Okay, my bad.
And no worries, thank you. But now probably you can see it, but it works. And although it's not a really good example, what I want to say is that no matter where you are in the application, you can just use the route and render whatever you need and reacting to the route, to the URL what is in the browser. So